In this problem, we're asked to find the relative maximum of a function. Our function is f of x equals 2x cubed plus 3x squared minus 36x plus 7. So in order to find the maximum on the graph, we'll look at the graph here that was given. I'm going to zoom in on that graph. And the relative maximum is the point at which the graph changes from increasing to decreasing. So the very maximum, the very largest y value on the graph that we see is right here. But that's not a relative maximum because the graph didn't change from increasing to decreasing there. That just happens to be the highest point on the part of the graph that we're looking at. So our relative maximum is actually right here. And we're not doing any computation to find that. And sometimes that's the confusing part. You feel like you should be computing it somehow, or it should be somehow obvious from the function what the relative maximum is. And in college algebra, that's not going to be the case. There is a way to compute the relative maximum from the function, but you have to take calculus to learn how to do that. So the only way we'll be able to tell is by looking at the graph and saying, okay, that point is a relative max because it's changing from increasing to decreasing. So it has to fall at a nice integer on the graph, otherwise you wouldn't know at what point you're getting that. So I can see that this looks right at about x equals -3. Now I want to know the y value. Let's clear this out of the way so we can see. And it's pretty hard to tell exactly where that's falling on the y-axis. But as long as we have our x value, we can take that x value and plug it in for x into our function that we're given. So let's do that. And I've already worked it out here. Okay, so we have f of -3 equals 2 times the quantity -3 cubed plus 3 times the quantity -3 squared minus 36 times -3 plus 7. And when you put that into your calculator, you get 88 as an answer. So that means that the function f has a relative maximum at -3 is our x value, and the relative maximum is 88. So the location of the maximum is your x value for that point, and what the maximum is the y value, and in this case that's 88. So that is the answer for part A. Now in part B we want to find a relative minimum. Okay, let's zoom in on our graph again. So if a maximum is where the graph changes from increasing to decreasing, a minimum is going to be where the graph changes from decreasing to increasing. And I'm going to say that's right about here. So now that's at an x value of +2. So here's my relative min. Again, I don't want to just estimate the y value, but the x value I do have to estimate. I don't have a way of computing that. All right, so now let's take a look at f of 2. So we have f of 2 is equal to 2 times the quantity 2 cubed plus 3 times 2 squared minus 36 times 2 plus 7, and that gives me a -37. So that means that we have a minimum, let's see, at x equals 2, and the minimum equals -37. Okay, so that's how we do that problem.